Namaskar. Today's topic is a presentation on Ansaldo Microlock 2, that is Hitachi electronic interlocking. This is the basics of Hitachi electronic interlocking. Here you can see Microlock 2 rack M1 PPM. This PPM is called a panel processor module. This is available where there is a processor or where there is a panel. This processor is available if a panel is also available along with the VDU. If there is no panel, this is not required. Now this is the interlocking module ILM. This is the hardware that you can see from the back side of the cabinet. Going further, these are all the hardware or the cards that are available in the cabinet. Here you can see this is system A and this is system B. Both systems will be working in standby mode, in hot standby, and generally one system which is working will be giving the output while the other system is ready to take any give output whenever system 1 is switched off or failed. What are the basic hardware parts or the cards that are available along with the motherboard? So here you can see the card file. This is basically a motherboard, CPU card, then we have a power supply card, vital input cards, vital output cards, non-vital input output card, both for input and output it is common. Then we have a sync card, or you can also call the synchronization card. This is the electronic communication board card, and VCOR or the vital cutoff relay. And apart from all this, we have the wiring hardware. Now let us go step by step and explain these cards in this presentation. So this is your card file. This is suitable to be mounted on a standard 19-inch rack. So these are all the cards available, and this is the card file. Here you can see in the card file, this is the place where the card's bottom connector is connected. This is a 96 pin connector, for all is a 96 pin connector, while the top is for external wiring यहाँ पे रहता है. This external wiring is 48 pin connector for vital cards and other cards, while it is also 96 pin for non-vital input output. That is the only difference between vital and non-vital cards. So 96 pin connector used to connect the motherboard here, while the 48 pin connector is used for connecting the external wiring that we bring into the cabinet. Each card file consists of 20 slots to accommodate various PCBs. So you can see here there are 20 slots. In this 18 and 19 is used for the CPU. Here you can see 18 and 19. In that place we have our CPU card, and 16 17 is used for power supply card. So these four places are standard for any MLK2. Slot 16 and 17 is used for power supply PCB, 18 and 19 for your CPU PCB, while slot 1 to 15 and even 20 can be used for various other functions like vital input, vital output, non-vital input, sync card, and even the communication board. These can be placed in any slots from 1 to 15 and 20 also, except 18 to 18, 19, 16 and 17. The back pin is provided for connecting all the slots. This is the back pin. Input supply is 12 volts DC. For Microlock 2 it is 12 volts DC for the internal system, and startup voltage to start the system it should be minimum 11.5 volts DC. If the input voltage is less than 11.5, the system will not start. Taking now coming to your CPU PCB. Here each card file has one CPU CP. So each card file has to be one CPU PCB. This is your CPU PCB. It is, as discussed, placed in the slot 18 and 19. The processor used by Microlog 2 is a 68332 Motorola, which has a speed of 21 megahertz. It has a 4 alpha numerical character display. Here it is there. The upper display is used for executive software display, while the lower one is used for application software display. The executive application software are provided are stored in floor flash EEPROMs of 8 MB. These are provided in the card. Now, what are the various indications available? Here you can see there are different indications. Indications on the left, you can see A to E are for serial communication ports. These communication ports will blink whenever they are being used. But if an electronic communication port or the ECB is used, these serial ports doesn't are not used if ECB is used. LED indications 1 to 8 are user defined or assigned indications, means these can be used according to our requirement. If we want any specific indication, then we can give the required command in the software, and indications for this can be user defined by us only. Next, you have a reset push button for conditional power supply and resetting system. This is your reset push button. While toggle switches for menu, adjustment and action purposes. These are the toggle switches 1, 2, 3, 4. These are used for various requirements for which has menu, adjustment and for action purposes, whether to accept that particular action or to reject it. Apart from that, we have resetting the CPSU signal adjustment and date through maintainer PC or toggle switches. Even maintainer PC can be used to adjust things or can be done with the help of the toggle switches. Total 5 serial ports are available. These 5 serial ports, we can see only one serial port, serial number 5, while other 1 to 4 are inside the PCB. 4 are inside PCB and connected through the jack. These are not used if communication is through ECB. Otherwise, these are also used. One on front side called the diagnostic port or even the digger port or maintenance port is being used even if ECB is available. This port is used to connect our laptop or PC so that we can do the required maintenance adjustments through that port. This PCB, as discussed, has a 48 pin connector on top while 96 pin connector on the bottom. This is going to the card file and this is for our external wiring. Apart from that, if you see at the back side of your CPU, this is what you see. This is basically called an E square PROM. E square PROM is electrically erasable, programmable, read-only memory. It is a memory or a just like a USB type card. You can see the card here, and here there are some wires with which we can connect that to our CPU. Why this is provided? Even if the CPU board is replaced, the configuration data remains intact within the EEPROM. So this is fed with our configuration data. Configuration data means which card, what is the address of each card, how they are connected. All this data is available in this card. If tomorrow you replace one CPU board, and if the software doesn't match with the already available data in this, the system will not work. Here you can see CPU PCB E square PROM. How they are connected via this is J1, J2, J3, J5, J6, J7. Here you can see J1 to J7. These are connected to our, this is your E square PROM and this is connected to your motherboard through these numbers. This is how your E square is interacting with your CPU. In that, as we have discussed, port 1 and 2 supports RS485, Port 3 supports RS-232 to 423 and 332, while port 4 and 5 supports RS-232 interface. Generally, ports 1, 2, 3, 4 are not used when ECB is used. Similarly, two fast static RAMs of 64 KB is used to process the vital data, and four low static RAMs, each again of 64 KB, is used to store events and errors. This is like your data logger, data storage. Apart from that, user data, you can have 90,000 events. Event data logging is 5,000 events, and error data log is of 50 numbers. Any errors that are available, 50 numbers will be available. So here first come first serve basis. जो पहले आता है वो पहले चले जाती है. In this, we have two types of software in the CPU. That is the executive software and the application logic software. This executive software and application software, what are the basic differences? This is prepared and preloaded by the company. It is common for all Microlab 2 systems, and it is for execution of application logic programming software. जैसे आप लोग एक कंप्यूटर खरीदोगे, उसमें माइक्रोसॉफ्ट ऑफिस जो है वो लगाया दिया जाता है, ओरिजिनल माइक्रोसॉफ्ट ऑफिस समझो वो एक एग्जीक्यूटिव सॉफ्टवेयर है। और आप खरीदने के बाद अपना लैपटॉप उसमें फाइल्स वो सब लगाएंगे, वो है एप्लीकेशन सॉफ्टवेयर, या एप्स, जो भी एप्स लगाओगे वो आपकी मर्जी का है, तो दैट इज एप्लीकेशन सॉफ्टवेयर. In this way, application software is customized. It is prepared as per station route control plan or the signal interlocking plan. It is different for all MLK systems. एक station, each station will have its own application software. It can be downloaded using the maintenance tool program on a laptop or a maintenance PC through the debug port that is available in front. Power supply PCB. Power supply PCB, here we have two indications. One is 5 volts LED, which is green color, while another one is all vital cutoff relay LED, which is green color again. So what does it indicate? When lit indicates 5 volts operating power on to other card file PCBs. So whenever this is a card file PCB, it is available, 5 volts is available. When it indicates conditional power on to vital cutoff relay. So if the power supply command is given by the CPU, then vital cutoff relay indication is available. Now the next one is your power supply PCB. The main work of this power supply is to convert the external power supply 12 volts DC, as we have said, into regulated plus 12 volts, minus 12 volts and plus 5 volts for outputs to the system card file, internal circuits through the card file. Here we have plus 12 volts, minus 12 volts for various functions, and 5 volts for all the internal for working of electronic items like processors and other things. Power supply PCB works is just like a DC-DC converter, while the startup voltage is 11.5 volts. If the voltage is less than 11.5, the system will not start. But once it starts, even then it will work between 9.5 to 16.5 volts. Each card file will have one power supply PCB, and it is placed in slots 16 and 17. Let us see through circuit also. Power supply PCB energizes vital cutoff relay when CPS signal is received from the CPU PCB. Here this is your CPU PCB. This is your power supply board. From CPU you are getting a 250 Hz frequency. 250 Hz conditional power supply, CPS. 250 Hz, this is a physical wire that you can see at the back side. Once 250 Hz frequency is available, this power supply will give output of 12 volts to pick up your vital cutoff relay. Until this supply is available, vital cutoff relay is picked up. So power supply PCB picks up vital cutoff relay, but under the condition that the 250 Hz frequency or the command from CPU is received. That is why it is called conditional power supply. The condition that 250 everything is okay. If there is any safety centric problem, then this 250 Hz is withdrawn by your CPU PCB. Then vital cutoff relay power supply is stopped by your power supply board. If the system detects any malfunctioning in its software or hardware, then CPS signal is withdrawn by the CPU PCB, and in turn power supply PCB cuts off power supply to your vital cutoff relay. Whenever this power CPU gets confused or any wrong information is given to it, then the power supply at 250 Hz frequency is stopped by your CPU, and power supply stops vital cutoff relay. Power supply. Vital input PCB. Each vital input PCB has 16 inputs. Here you can see 16 inputs. Each card can have 16 inputs, and each input is designed for detecting out there gates. For example, ECRs, NWKRs, RWKRs, TPRs. For all the data that is coming from outside, we are having this input card. These are double cutting circuits, that is positive and negative side. It can be placed as discussed in 1 to 15 and 20 slots also, generally depending on the inputs. 4, 3, 4 or 5 cards are used. Its top and bottom pin connectors are of 48 and 96 pin respectively. Top pin connector is for physical wiring and bottom pin is plugged into the cardboard file. If you see the circuitry, how a input is given, here you can see this is your, let us say, some 18 RWKR input. So 18 RWKR input relay, this relay picks up from the supply that is coming from the location. Once this relay is picked up, we are giving the input supply like this to your vital input PCB. Negative black wire we are giving like this. So you can see this is for system 1 A system, while this is for system B system. As we have said, two systems are working, A system, and here you can see all these are going to B system in parallel. Wires, generally we use blue and black colored twisted pair provided for vital input circuits, which is of 16 by 02. Vital output PCB. Each vital output PCB can again have 16 outputs. Input 16 था, अभी output भी 16 है. It can be placed in 1 to 15 and 20 slots. Same thing. Top and bottom pin connectors are 48 and 19 pin respectively. Top pin connector is for physical wiring. Bottom pin again is for motherboard wiring. These are continuously monitored by the CPU. Any abnormality present in the output will lead to system reset and shutdown in the shutdown to ensure safety. So again, if there is any problem, the CPU will shut down. How output is connected? So this is the input we have given to the card. A16 and A22 are the pins through which input is given, 24 volts. Then whenever this gives command for picking up of, let us say, shunt 21HR, supply will come through this. This is bit 1 or bit 1 of slot 4. Here it is coming supply like this, and as shunt 21HR is picked up. The negative is given directly from outside to this relay. So only positive single cutting is coming through to pick up this relay. If system, let us say A system is working, if B system is working, the same supply is coming from here. Here you have diodes, so that this supply which is coming like this will not come back. Similarly, this supply has to go like this, it cannot come back. That is the reason why we have provided diodes here. Generally, gray, red or black color wires of 16 by 02 are provided for vital outputs. Non-vital input output. Non-vital inputs are panel push buttons and keys of domino operating panel. Generally, non-vital input output PCB is used where there is a domino panel, and all push buttons, keys, everything will become inputs for the PCB. While non-vital outputs are the indications that are available on the panel. Presently, this card's usage is very limited because panel processors are now not required and are not being provided. Some indications only are given through this. Non-vital input card, here you can see, let us say yeah, S30D2DR. This is the relay that has picked up. From here I am giving the input supply. This is your feedback. So once I have picked up DR relay, that feedback is required to know if the relay has actually picked up or not. So this becomes a non-vital input, S30D2DR feedback supply. This is not vital, this is only non-vital, just feedback whether the relay has picked up or not. And non-vital input, this is how the wiring is available. Thank you. Jai Hind. Let us meet in part 2.